Imagine a time before time, when our solar system was a swirling cloud of dust and gas. This cloud, called a nebula, was the birthplace of our planet. Gravity pulled the particles together, forming a spinning disk. At the center of this disk, a star ignited, our very own sun. Further out, the remaining dust and gas continued to collide and clump together. These clumps grew larger over millions of years, eventually forming planets. One of these planets, a fiery ball of molten rock, would eventually become our home, Earth. The early Earth was a hostile place. Volcanoes erupted across its surface, spewing lava and gases into the atmosphere. The planet was constantly bombarded by asteroids and comets, leaving behind massive craters. It was a time of intense heat, constant upheaval, and unimaginable violence. This period of intense bombardment, known as the Late Heavy Bombardment, played a crucial role in shaping the early Earth. These impacts delivered water and other volatile compounds to our planet, essential ingredients for the emergence of life. As Earth cooled, its molten surface solidified, forming the first crust. This crust was thin and constantly broken by volcanic activity. The atmosphere was thick with noxious gases like methane, ammonia, and carbon dioxide. There was no oxygen, the life-giving gas we breathe today. Over time, Earth's interior continued to cool and solidify. This led to the formation of a solid inner core, a liquid outer core, and the mantle, the layer between the core and the crust. These layers constantly interact, driving geological processes like plate tectonics and volcanic eruptions. This early atmosphere was also devoid of a protective ozone layer. This meant that the surface of the Earth was bathed in harmful ultraviolet radiation from the sun. This radiation would have been lethal to most forms of life as we know it. Despite the harsh conditions, this early Earth was a cauldron of chemical reactions. The stage was set for the emergence of something truly extraordinary: life. Where did all the water that fills Earth's vast oceans come from? Scientists believe that a significant portion arrived on Earth through a bombardment of icy comets and asteroids from the outer solar system. These icy bodies, remnants from the formation of the solar system, crashed into the young Earth, delivering their precious cargo of water. As Earth cooled, the water vapor in the atmosphere condensed. Torrential rains lashed the planet for millions of years, filling the first basins and depressions in the Earth's surface. These basins eventually became the first oceans. The formation of oceans was a pivotal moment in Earth's history. Not only did they provide a stable environment for life to emerge, but they also played a crucial role in regulating Earth's climate and shaping the continents. The oceans, teeming with dissolved minerals from the Earth's crust, became a primordial soup, a fertile breeding ground for the first life forms. The stage was set for the next chapter in Earth's story, the emergence of life. Beneath Earth's crust, a dynamic process was unfolding. The intense heat from Earth's core created convection currents in the mantle, the layer beneath the crust. These currents caused the Earth's crust, broken into massive plates, to move and shift. This process, known as plate tectonics, would shape the face of our planet. Over millions of years, the continents we know today drifted across the Earth's surface. They collided, forming towering mountain ranges like the Himalayas. They pulled apart, creating vast ocean basins like the Atlantic. These continental movements had a profound impact on Earth's climate, ocean currents, and the evolution of life. They created isolated land masses, leading to the diversification of species. They also influenced the distribution of heat around the globe, playing a crucial role in regulating Earth's temperature. The Earth's surface was no longer a static, unchanging landscape. It was a dynamic, ever-evolving stage shaped by the forces of plate tectonics. This continuous dance of the continents continues to this day, a testament to the restless nature of our planet. Section 5. Life finds a way, the first spark. The early oceans, teeming with dissolved minerals and bathed in energy from the sun, became the cradle of life. Scientists believe that life arose in these primordial seas around 3.5 billion years ago. The exact details of how life emerged from non-living matter remain one of the most profound mysteries in science. One leading theory suggests that life arose in volcanic vents on the ocean floor. These vents release heat and chemicals from Earth's interior, providing the energy and raw materials for the first life forms. Another theory proposes that life originated in shallow pools of water on the early Earth. The earliest life forms were simple, single-celled organisms similar to bacteria. These organisms were prokaryotes, meaning they lacked a nucleus and other complex cellular structures. They were able to harness energy from their environment and replicate themselves, the defining characteristics of life. The emergence of life marked a profound turning point in Earth's history. Our planet was no longer a barren rock hurtling through space. It was now a living world, teeming with the potential for complexity and diversity. Section 6. From single cells to complex creatures, life evolves. Over billions of years, life in Earth's oceans underwent a remarkable transformation. Through the process of evolution driven by natural selection, simple single-celled organisms gave rise to an astonishing diversity of life forms. A pivotal event occurred around 2.5 billion years ago with the evolution of photosynthesis. Certain organisms developed the ability to harness energy from sunlight to convert carbon dioxide and water into sugars. This process released oxygen as a byproduct, gradually transforming Earth's atmosphere. The rise of oxygen in the atmosphere had a profound impact on life. It paved the way for the evolution of more complex oxygen-breathing organisms. It also led to the formation of the ozone layer, which shielded Earth's surface from harmful ultraviolet radiation. The stage was set for the Cambrian explosion, a period of rapid diversification of life forms around 540 million years ago. During this time, most of the major animal phyla that exist today emerged, showcasing the incredible power of evolution. Section 7. A Walk Through Time. The Age of Reptiles. Life continued to evolve and diversify, eventually making its way onto land. Plants colonized the continents, followed by insects and amphibians. Reptiles, with their waterproof skin and amniotic eggs, were well suited to life on land and rose to prominence. The Mesozoic era, spanning from 252 to 66 million years ago, is often referred to as the Age of Reptiles. Dinosaurs, a diverse group of reptiles, ruled the Earth for over 180 million years. They evolved into a wide range of shapes and sizes, from the massive, long-necked sauropods to the fearsome Tyrannosaurus rex. The Mesozoic era wasn't just about dinosaurs. It also witnessed the evolution of birds, the descendants of feathered dinosaurs. Mammals, small and mostly nocturnal creatures, also emerged during this time. They lived in the shadows of the dinosaurs, awaiting their chance to take center stage. The reign of the dinosaurs came to a dramatic end 66 million years ago, when a massive asteroid collided with Earth. The impact triggered catastrophic events, including widespread wildfires, tsunamis, and global cooling. This marked the end of the Mesozoic era and ushered in a new chapter in Earth's history. Section 8. Mammals inherit the Earth. With the demise of the dinosaurs, mammals had an opportunity to diversify and thrive. They evolved into a wide range of forms, filling the ecological niches left vacant by the extinction of the dinosaurs. Some mammals took to the skies, evolving into bats. Others returned to the oceans, giving rise to whales and dolphins. Among the most successful groups of mammals were the primates, which evolved from small, tree-dwelling creatures. Primates possessed several adaptations that allowed them to thrive in their arboreal environment, including grasping hands, binocular vision, and relatively large brains. Over millions of years, a lineage of primates known as hominids evolved in Africa. Hominids are characterized by their upright posture, bipedal locomotion, and increasing brain size. These adaptations allowed them to exploit new resources and environments. The evolution of hominids culminated in the emergence of our own species, Homo sapiens, around 300,000 years ago. Humans, with their large brains, complex language, and ability to manipulate their environment, would go on to have an unprecedented impact on the planet. Section 9. A planet transformed, life's enduring legacy. From a lifeless rock orbiting a newborn star, Earth has undergone a remarkable transformation. Over billions of years, our planet has been shaped and reshaped by geological forces, astronomical events, and the enduring power of life. The emergence of life, perhaps the most extraordinary event in Earth's history, has fundamentally altered our planet. Life has transformed Earth's atmosphere, oceans, and continents. It has created the conditions necessary for its own survival and diversification. Today, Earth stands as a testament to the resilience and creativity of life. From the smallest microbes to the largest whales, life teems in every corner of our planet, a symphony of diversity and interconnectedness. As we look back on Earth's epic journey, we are reminded of the preciousness of our planet, and our responsibility to protect it. The story of Earth is not over. Our planet continues to evolve, shaped by both natural forces and human activities. As we look to the future, we have the opportunity to learn from the past, to appreciate the interconnectedness of all living things, and to become better stewards of our extraordinary planet. The future of Earth is in our hands.